Hello everyone, myself Manoj. I'm from Shri Venkateshwara College of Engineering, Department of Electronics and Communication. Today I'm going to discuss about real-time system development methodologies. Real-time systems are those in which the correctness of system depends not only on the logical result of computations but also on the time at which the results are produced. These systems are commonly found in areas such as embedded systems, control systems, telecommunications, and more. Here are two real-time system development methodologies. First one is waterfall mode for real-time systems. The waterfall mode is a traditional and linear approach to software development consisting of distinct phases that are executed sequentially. In the context of real-time systems, the phases of waterfall model can be adapted to incorporate real-time considerations. The typical phases include requirements, design, implementation, verification, and maintenance. In the requirements phase, it's crucial to capture real-time constraints and deadlines. The design phase focuses on both functional and temporal aspects, ensuring that the systems meets its timing requirements. The implementation phase involves coding with real-time considerations in mind, such as minimizing response times. The verification phase includes testing the system's real-time performance. One advantage of waterfall model is its structured and easily understandable nature. However, it may not be as flexible as more iterative approaches, and changes are challenging to incorporate once a phase is completed. Phases of the waterfall model: requirements gathering and analysis, system design, implementation and coding, testing and validation, deployment and maintenance. Each phase of the waterfall model is completed before moving on to the next one with no overlap between phases. This means that each phase must be completed and signed off on before the next phase can begin. While this approach can be rigid and inflexible, it is often used in real-time system development because it provides a clear structure and helps ensure that each phase is completed thoroughly before moving on to the next one. Benefits and challenges of waterfall model. Benefits: waterfall model is a linear and a sequential approach that is easy to understand and use. It allows for a clear definition of requirements and deliverables, reducing ambiguity and increasing clarity. It provides a well structured approach to development, with each stage building on the previous one. It is suitable for projects with stable and well defined requirements where changes are unlikely to occur. What are the challenges that we face in a waterfall model? It can be built to make changes once a stage is completed, making it less flexible than other models. It can be challenging to estimate the time and resources required for each stage, leading to delays and cost overruns. It may not be suitable for projects with changing or dynamic requirements, as it does not allow for flexibility and adaptation. It can lead to a lack of collaboration and communication between teams as each stage is completed before moving on to the next one. V model for real-time system. The V model is an extension of the waterfall model and is characterized by its emphasis on testing at each stage of development. In V model for real-time system, each development stage has a corresponding testing phase, forming a V-phased structure. For example, the requirements phase is paired with the system testing phase, design phase with integration testing, and so on. Real-time considerations are integrated into each phase, and testing is particularly critical for validating timing requirements. Unit tests, integration tests, and system tests should include scenarios that verify the system's response time and adherence to deadlines. The V model is beneficial for real time systems because it highlights the importance of testing early and continuously. However, like the waterfall model, it can be less accommodating to changes once the project is underway. Benefits: structured approach. The V model provides a structured approach to software development with a clear sequence of phases. This can be beneficial in real-time systems where predictability and reliability are crucial. Early testing. Since testing activities are planned in parallel with development phases in the V model, it allows for early detection and correction of defects. In real time systems where errors can have critical consequences, early testing is highly valuable. Traceability. The V model emphasizes the importance of traceability between the various development phases. The traceability can be beneficial in real time systems to ensure that each requirement is met and that changes are well documented. Clear milestones. The V model provides clear milestones at each stage of development. This can be useful in real time systems to track progress and ensure that the project stays on schedule. Challenges. Rigidity. The V model can be perceived as rigid as it follows a sequential approach. In real time systems where flexibility and adaptability are often required, this rigidity may pose challenges, especially if there are changes in requirements. Late feedback. While the V model emphasizes testing at various stages, the feedback loop can be relatively late compared to more iterative models. In real time systems where quick feedback and adaptation to changing conditions are critical, this delay can be a challenge. Assumptions of stable requirements. The V model assumes that the requirements are stable throughout the development process. In real time systems where requirements may evolve due to changing conditions or emerging constraints, these assumptions may not hold, leading to potential challenges. Limited user involvement. The V model may not involve users as much during the development process, especially in comparison to agile methodologies. In real time systems where user feedback is crucial, this limited involvement can be a drawback. Both the waterfall model and the V model can be adapted to suit real time systems by emphasizing the inclusion of timing and scheduling considerations at each stage of development. However, in practice, many real time systems often adopt more flexible and iterative methodologies, such as rational unified process or agile methodologies, to better accommodate the dynamic nature of real time requirements and the faster adaptability throughout the development process. Thank you. That's all for today.